Hi, I'm Adam, and I'm introducing our project to create a web app for converting map paths to a series of Bezier curves for simulation playback. In our group, we have Matt, Ethan, me, Kevin, and Mohammed. You'll meet them later on in the video. Our sponsor is Andrew Pelican, and our instructor for this class is Ming Zhao. So for our project overview, basically in the very beginning, we were just giving an idea that Bezier curve algorithms existed, and they wanted a web app that allows users to interact and see the Bezier curve algorithm process. They weren't really giving us any specific ideas to what to do. They wanted us to actually come up with the idea ourselves. So that was part of the fun of the project itself, though. What Bezier curve algorithm is basically it's an algorithm that converts points into a curve that can be stored, and then it's also goes the other way where you can take the curve that you've created and go back and make points out of a curve itself as well. Some of the things it can be used for is also it can be used to compress data points. So if you have a bunch of data points, say stored from stops of an Uber driver or points that maybe a delivery truck does on a route, you can store all those data points of those stops and locations from a map as just one single curve, so it can compress that data significantly. Also can be used to manipulate, like for artists, can manipulate drawings with this, because if you take a curve of an artist drawing, you can actually convert that to points. Those points can be modified using other algorithms or other ways to modify those points, and then you can convert back to a curve, and now your new curve could be better than what you had originally made.
I'm going to go over the requirements for the Bezier application. So some of the requirements for this document are that we have to develop a robust web application that gives the user the ability to draw paths and record that data for testing purposes. We also need to come up with an idea of how to use these Bezier curves and how the web application will work and what it does when it is finished. That we also need to get the approval of our sponsor and stakeholder of the major project from our sponsor. And we also need to identify how the Bezier curves can be stored and edited. We also need to develop a solution for compressing a set of data points and for retrieving points from an edited curve. This mainly has to do with NumPy and the similar Python packages. Simple manipulation of data. We also need the ability to store less points and to plan alternate plans for the path the curves will follow. Some of the tools and technology that we will need: HTML, CSS, JavaScript, Python, data handling, and NumPy. Now NumPy, we're using NumPy for the data structures that it comes with the matrices and the curve building. The Bezier Python package that we are using requires NumPy data structures. So NumPy is a very large part of what we're doing. And we also use Flask to pass data from the GUI to the backend and back and forth. And we're also going to need linear algebra, given that we are working with matrices and math with matrices. That is the tools and technologies.
So I worked on the front end along with Kevin, and we primarily used HTML, CSS, and JavaScript, which is basic web app stuff, giving it a mock-up, buttons, all that. And what we really wanted to focus on was the design and then linking the front end with the back end, which was worked on by Ethan, Adam, and Mohammed. The back end was made with Python. Now, how we made sure that we created a connection was by using Ajax in the front end, which is brought in through JavaScript, and Flask in the backend, which will allow for routing, allowing going back and forth between the two. Now, as for our actual web app, the project, this model is pretty basic. It has a canvas for you to draw on, see points, and do all of your calculations on. Our buttons, we'll start with the get map. The get map will load an image that you have to use for any kind of plotting or finding out a better curve within the image. Set points will set points along that image. The get points will obtain new points after they're converted using a Bezier curve. Load curve will load a saved curve that's already created. Plot curve will create a curve based on the points that are on there. And draw curve will allow you to freely draw on the canvas. We have an edit button here, which will allow us to make some changes in case there's any points or random extra parts of a curve that we want out of there that might create outliers in data. A save button to save what we're working on for later, which you can see we can load the curve or we could get the points from both from saving, and a clear button which will allow us to clear the whole canvas after we're done using. Now I'm going to go over the actual, we'll start with the used. So in one prototype, I made sure that we can see exactly what's happening by having the X and Y coordinates shown on the canvas itself. These coordinates will change and track where the mouse is because these are the points. Now when I click it, a line can be starting to draw, and this line is being saved, as in each point is being saved, each XY coordinate, in an array. It'll disappear after it in this version because it's done saving. That's not exactly what we want, but this is exactly what we wanted to see before we could send it over to the Python backend. Now, as for our main prototype, what we have worked on so far was being able to draw on this canvas and leave it there. We can store the points in the back using the same functions used in this prototype. And right now, we can clear that and create a new one. Currently, we have been stumped on using the Ajax Flask back and forth to set all the points up, get the points and functions. So combining the front and back end is really where we're having some difficulties, but we've been working through it, and I feel like we're in a good place.
Hello, my name is Kevin, and doing what lessons we've learned. First is a good chance to work with a team and share responsibilities to complete a project. Second is time management for which part we're doing to be able to finish our parts. And second is to have meetings with each other to know what we're going to do and to make sure there's no conflict in that. The third is the importance with talking with our sponsor to get feedback and to know what requirements he wants us to do for that.
Hi, I'm Mohammed. I'm gonna talk about the conclusion. Good experience. At first, none of us had any idea about Bezier curve, and all of us just wanted to work on the machine learning project, deep learning project, AI project, and that's how we choose that project as our capstone. And to be honest, I have never heard the word of Bezier curve, so it was really cool thing for all of us to work on the real world project, which was new to us, and we didn't know anything about that previously. Tons of research done and still needed. Actually, first, Andrew gave us the idea about the web app with usage of Bezier curve. We were required to come up with the functionality of that web app, and it took us a few weeks to understand this idea, so we can come up with the something functional. Over those weeks, we came up with the idea to create a web app for converting a map path to a series of Bezier's curve. And as you saw previously, Matt showed you the GUI, the prototype, and you can see how that works. As I mentioned before, because this concept was new to us, we had to do lots of research to understand just the definition of Bezier curve, how it works, how the algorithm works, doing research about the Bezier Bezier package in Python, like how to use the function, how to use the methods, how to implement it. And at this point, we're not done with our research yet, and we're still working on it. Elements for effective teamworks. Probably like commitment and trust, communication, diversity of capabilities. And the final thing that I'm going to say, remember, teamwork makes the dream works.